For a simple random sample of pulse rates of women measured in beats per minute, sample size n is equal to 147 and the sample standard deviation is 12.3. The normal range of pulse rates of adults is typically given as 60 to 100 beats per minute. If the range rule of thumb is applied to that normal range, the result is a standard deviation of 10 beats per minute. Use the sample results with a 0.05 significance level to test the claim that the pulse rates of women have a standard deviation equal to 10 beats per minute. See the accompanying JMP display that results from using the original list of pulse rates instead of the summary statistics. Now hint, the bottom three rows of the display provide p-values for a two-tailed test, a left-tailed test, and a right-tailed test respectively. What do the results indicate about the effectiveness of using the range rule of thumb with a normal range from 60 to 100 beats per minute for estimating population standard deviation in this case? And assume that the simple random sample is selected from a normally distributed population. So when we open up the display, it says the hypothesis test value for this one says the value is 10, and then there's the actual estimate, there's the degrees of freedom, and they're testing the chi-square distribution. There's the test statistic, there's the minimum p-value, and again we talked about whether it's for a two-tailed, left-tailed, or a right-tailed test here. Okay, now some of these values we're going to go ahead and check with our values. So let's go ahead and do that. So the first thing we're going to do is let's go ahead and determine what is the claim for this particular question. So we're going to go ahead and highlight that. All right, so the highlighting the claim, so it says we want to test the claim that the pulse rates of women have a standard deviation that is equal to 10 beats per minute. So again, it's always important to first identify that so you know what you're testing. Okay, and now what else do we need to know? Well, we know that we have the sample size, and then we know that we have the sample standard deviation. So those are the things we want to make sure we write down and identify. So we know that the sample size is given to be 147. Okay, we know that the sample standard deviation is rounded to 1 decimal place. Now when they're using the display, it's not actually being rounded, it's actually using all the data. Okay, so you round at the very end of that sample standard deviation. And then from the claim, we can see that the population standard deviation is going to be equal to 10. Okay, so now let's go a little further. Now the requirements. Now the first requirement is that the sample is a simple random sample. So this requirement is satisfied since it is given that a simple random sample is selected. And number two, the second requirement is that is a fairly strict requirement the population has a normal distribution. Now, if this requirement is not satisfied, then an alternative method should be used to test the claim. Now, this requirement is satisfied since it is assumed that the population is normally distributed, so therefore both requirements are satisfied, and the primary method for testing the claim about a population standard deviation can be used. Okay, now let's take a look at the claim and the opposite of the claim. So we're just going to verify what we want to write here. So we know that the claim is the fact that the population standard deviation is going to equal 10. And then the opposite of that claim would be that the population standard deviation does not equal 10. And so this is going to allow us to identify the null and the alternative hypothesis. So the null hypothesis always contains the equality. So we know that the population standard deviation is going to equal 10, and that matches with the claim. And so therefore the alternative hypothesis is now going to be not equal to 10, and that comes from the opposite of the claim. Now let's go ahead and then put in our answer here. So we know the population standard deviation for the null is going to be equal to 10, and the alternative hypothesis is that it's not equal to 10. And let's check our result, and there's our answer. Now we want to identify the test statistic. Now from the display, we can see what we get from the display. Okay, so the display of the test statistic is 222.3120. Now this is collecting all the data and then using that data. Now we may come up with a different number, but before we do that, let's go ahead and identify the following. We're going to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Since it's not equals, we know that we are dealing with a two-tailed test. Okay, and also we want to know what the significance level is, and it's given up here that we're testing it at 0.05. Okay, and then we're going to find a test statistic. Now remember that we set up at the top here that n is equal to 147. We know that the sample standard deviation is 12.3 and the population standard deviation is 10. Now, because of the fact that this number is rounded, we're not going to get the exact number that we get here, but we're going to get it close. So we're going to get 147 minus 1 times the sample standard deviation of 12.3 squared over 10 squared. Okay, so let's see what we get for that result. All right, so we know that this is going to be 147 minus 1, which is 146, and then times 12.3 squared. And then we're going to divide it by 10 squared, which is 100. And then we're going to round that to 2 decimal places. So we end up getting 220.88. Okay, now let's compare it to what we get up here for the test statistic. Okay, so just want to make sure that we can see what it looks like when you compare it. Now again, the reason why our number is slightly off is because this standard deviation is rounded when we put it in. So this is the number that we want to put in, which is 222.31, because they want us to round that to 2 decimal places. So that's what we're going to put over here. 222.31, and that's coming from the display. Okay, now we want to identify the p-value. Now, they're given the p-value here. It's saying that the minimum p-value is less than 0.001, and the first one represents the two-tailed, and then the left-tailed and the right-tailed. So let's go ahead and do that. So we're going to go down here, and then we're going to draw our curve and label that. Okay, now remember this is a right distribution for the chi-square, and it's a two-tailed. So we know the chi-square value that we got, the test statistic, is 222.31. So in order for us to find the p-value, we need to first find the degrees of freedom. The degrees of freedom is taking the sample size of 147, subtracting 1, which gives us 146. And now in order to find the p-value, what we're going to do is first find the probability of when that test statistic is greater than or equal to 222.31. And then once we get that p-value, we're going to multiply it by 2 since we have two tails. So let's go ahead and put in our StatCrunch here. Okay, so we're going to go to Stat, Calculators, and then go to chi-square. We're going to put in our degrees of freedom, which is 146. We're going to make sure that this says greater than or equal to. And then we're going to put in a test statistic of 222.31, select compute, and there is our value. So there is the p-value that we get for the one tail. So there's the p-value for one tail. Okay, so what we're going to do with that p-value is we're going to multiply that by 2. So let's multiply this number by 2 to get our p-value. So we're going to go ahead and put that in our calculator. We have 2 times 0.00004801, and then we're going to round that to 2 decimal places. So that's going to give us 9.6 times 10. So this is 9.6 e to the negative fifth, which is the same thing as 9.6 times 10 to the negative fifth. Which means we're going to take this decimal and move it over 5 times. There's 1, 2, 3, 4, 5. So there's our decimal. And so they want us to round this to 3 decimal places. And so when we round up to 3 decimal places, we're going to get a p-value that is 0.000. And then if you come back up here, it's saying that the p-value is less than that, which is 0.00 round to 3 decimal places. So let's go ahead and put that in there. 0 is our answer, and there is our result. Okay, now we need to state our conclusion. So now that we found our p-value, we're going to compare that p-value rounded to 3 decimal places to our significance level, which is 0.05. Now, if the p-value is less than or equal to the significance level, we reject the null. If it's greater than the significance level, then we fail to reject the null. In this case, this number is less than the significance level, and therefore we're going to reject the null hypothesis. Okay, so now that we reject the null hypothesis, now we want to state our conclusion. So we need to go back and take a look at the original claim and then decide which conclusion that we want to use. So when we come back up at the original claim, you can see that the original claim included the equality sign. So therefore, in the first two, it says original claim does not include equality. Well, it does, so we're going to eliminate those two. And there we said that the original claim does include equality, and now we rejected the null. So that means we're going to use this scenario, and therefore we're going to say the following. We're going to say we're going to reject the null hypothesis, and then there is sufficient evidence to warrant rejection. So let's go ahead and put that in here. So we're going to say reject the null hypothesis, and that there is sufficient evidence to warrant rejection of the claim that pulse rates of women have a standard deviation equal to 10 beats per minute. And so we can say that the results indicate that there is significant evidence that using the range rule of thumb with the normal range from 60 to 100 beats per minute for estimating a population standard deviation is not effective in this case. Check our answer, and there is our result.